Hello and welcome back to section 5 of the course, where we'll talk about serverless architecture. In this section, you'll get an introduction to the concept of serverless computing and its benefits. We'll also demonstrate how we can build a serverless application, what are the caveats we should consider, and what are the main differences to regular applications. We will cover 4 basic parts. We'll start by introducing the concept of serverless computing, looking at the benefits that make it worth investing time into. We will then look at how we can use an AWS service called Lambda to migrate one of our services to the serverless model. In the next topic, we will investigate how the development lifecycle differs between regular and serverless applications. In the last part, we will conclude by explaining some of the caveats of serverless computing and look at some cases where it might not be the best choice. In this first part, we will make an introduction to the term serverless computing, give a general overview of how it works, and what are the main benefits it brings. First of all, let's have a quick look at the term serverless computing and what it means. Because of its origin, this term has created several misunderstandings, since some people believe that it's a way to execute software without running any server at all. Of course, this is not possible. On the contrary, serverless computing is a model where we can execute software without caring about where the software will be executed. In reality, the software is being executed in a server, but this is managed by the cloud provider and is opaque to us. Let's start by looking at what the programming model of serverless computing is. The developer can define and register a function. Then there are various ways to make use of this function. One way is to trigger the function based on some request of the user and return the function's result back to the user as an HTTP response. Another way is to trigger the function as a response to an event that happened. To give an example, a function can be executed every time a user is uploading a file in a specific location. Lastly, we can also trigger this Lambda function programmatically from a different piece of code. The main enabler for serverless computing has been the concept of containers. We don't have a lot of time to explore this concept, but briefly, it's an alternative to virtual machines, which allows us to have many processes in a single machine, which appear as different machines that are very lightweight and fast to start up. To achieve the illusion of serverless computing, we can have a pool of servers and execute these functions inside separate containers. The main workflow is the following. Every time a function needs to be invoked, the platform checks whether there's an alive container running that function already. If not, then a new container will be started and the function will be executed in it. If there is an alive container, the platform might check whether this container is able to execute one more function. If that's true, the function will be executed in the same container, otherwise a new container will be started. Of course, the platform is responsible for other tasks, such as shutting down idle containers to save resources, and scaling the pool of servers based on the incoming traffic to ensure there will always be available servers for new functions. Of course, keep in mind that this is a simplified overview, which might differ between implementations and providers. Now that we've seen how it works, let's explore what are the main benefits of serverless computing. The biggest benefit serverless computing brings is cost efficiency. When running regular applications, we pay for the resources we use regardless of how much we use them. However, in the serverless model, we are being charged on the number of times our function is invoked. As a result, we don't have to pay any more for idle servers, saving a lot of money. Another significant advantage is reduced operations, since the management of servers is now fully done by the cloud provider without us having to do anything. On top of that, the serverless model can increase productivity in software development. Engineers can skip writing a lot of infrastructure boilerplate code and only write the business logic code. For instance, engineers don't need to write multi-threaded code since the model already provides parallel execution by default. Last but not least, less work is required to make the application scalable, since most serverless platforms provide auto-scaling capabilities. Of course, this comes with some caveats that we'll see in the next parts. There are two main ways to leverage serverless computing for our applications. The first and easiest way is to use services provided by cloud providers. The serverless ecosystem has been developing with fast pace. As a result, you can easily confirm that most of the major public cloud providers have offerings for developing serverless applications. However, there are also frameworks that can help us create such a platform in our on-premise private data center. This means that we will be able to utilize our resources more efficiently, allowing us to minimize idle time. Still, we probably won't be able to have the elasticity that public providers can offer by having much larger resource pools shared across all their clients. In this video, we made an introduction to the term of serverless computing, how it works, and what are the main benefits.